Good morning, students. Once again, welcome back. Here I am just going to discuss of your class 11 mathematics. Okay, which you are looking forward with eagerness and interest. Yes, which is the most vital chapter. I am going to discuss chapter 1 set theory. Okay, here I am going to discuss the introduction of the set theory. And yes, students, class 11 mathematics, you are all going to class 11 after your class 10. You have done fantastic in your exam and you are looking forward, okay, to class 11. And your students, class 11 math is the most vital mathematics which laid the foundation to class 12 math. Relation and function are most vital chapter to calculus, and without which the calculus is never understood. The calculation is the study of the derivative and integration and their practical application in various fields of mathematics and science, mostly physics, okay, and engineering. So without calculus, you can't understand, it is difficult to understand. Similarly, set theory is the most vital chapter which gives the clear understanding and idea about the relation and function, without which the relation and function is never understood. So you have to take importance of these chapters, and it has wide application, set theory, okay, and various application and importance and significance in solving the various problems, besides giving the idea about the relation and function. Okay, so here I am discussing the introduction set theory. The basic concept I am going to explain, and also I have discussed the SHARMA solution of exercise, first chapter, first exercise, okay, based on the concept of the set theory which I am going to discuss here. I hope you will understand and you will go through the class and you will understand the concept. The class has been vividly explained, lucidly explained for you, okay. Take interest of the class. Yes, set theory is the first chapters of your class 11 which I am going to discuss here. And set theory has many applications and significance in our practical life. It is widely applicable in our everyday life. Mathematics in our everyday life, okay. Without the knowledge of set theory, it is very difficult to understand. Look at an interesting question here. In a school, all pupils play either hockey or football or both. 400 play football, 150 play hockey, and 130 play both the games. Find the number of people who play football only, the number of people who play hockey only, the total number of people in the school. An interesting problem. Only can be solved with the help of the set theory, with the knowledge of the set theory. Similarly, set theory has many applications in everyday life. Here is another question, interesting question, vital questions. Such kind of questions only can be solved with the help of the knowledge of set theory. So, it has significance, it has importance, okay. So, you have to take care of these chapters with utmost attention. Set theory in everyday mathematics. Here is another question. See how interesting the question is. Logical question, vital questions, and this kind of question only possible through the knowledge of set theory. So the set theory has wide application, set theory and set operation, right? Okay. So this set theory, who is the founder of set theory? This set theory, again you see the set theory in everyday life. You see the problem is there. So it's an interesting and amazing problem for you, okay, and which can be solved with the help of the set theory. So who is the founder of set theory? Who is the creator of set theory? Who is the initiator of set theory? George Ferdinand Ludwig Philipp Cantor was born March 3, 1845, St. Petersburg, Russia. Died January 6, 1918, LA, Germany. Was a German mathematician, was the founder of set theory. So George Cantor was popularly known as the founder of set theory. George Cantor was the founder of set theory, was the initiator of set theory. The concept of set theory was initiated by George Cantor. So what do we mean by set? Define set. Set is nothing, is a collection. A set is a collection of well-defined elements. What is set? Set is a collection of well-defined elements or object or members. Okay. For example, the set of geometry box. If you say the geometry box, it is useful in different geometrical activities. The elements must be well defined. These are the elements, members, or the object of the geometry box. The collection of objects. So set is a collection of objects. Okay. Hence, the scale belongs to geometry box. The object are well defined, belongs to the symbol stands for belongs to, or scale is an element of the set geometry box. I will discuss the symbol belongs to. The belongs to means is an element. Mathematical notation, set notation. Okay. Scale belongs to set of geometry box. Compass belongs to set of geometry box. Eraser belongs to set of geometry box. But the spoon does not belong to geometry box because during the geometrical construction or activity, the spoon is not required, and the spoon is not the element which is not required, okay, for any geometrical activities. The element is not well defined. So the elements spoon is not well defined for geometry box. This is understood that the element of a set must well defined, and set is a collection of well defined elements. Once again, see, the compass belongs to geometry box, is required, inevitable, essential for any geometrical activities and construction. Yes, so the compass is an element, and the element of a set is well defined. Similarly, the protractor belongs to geometry box, and also, okay, for geometrical activities, for construction of angles and different kind of geometrical process and activities. Element of the set is well defined. The protractor is required, without which the measurement of angle is not possible. Scale belongs to set of geometry box, is required without to draw a line or perfect measurement, accurate measurement, without which we cannot draw a line segment and geometrical construction. So the element of set is well defined. But spoon does not belong to geometry box, set of geometry box, because it is not required to construct any kind of construction. Spoon is not required to any kind of geometrical construction. So it is clearly understood that, observe that, element of a set is well defined and set is a collection of well defined elements. How to represent a set? A set is usually represented by the capital letter of English alphabet, such as capital A, capital B, capital C, capital D, etc. Elements of set are represented by small letters of English alphabet, such as small a, small b, small c, small d, etc. Also, element can be expressed with the help of the numbers and different kind of symbols. Beside this, if A is an element of the set A, we can write as notation A belongs to A, read as A belongs to A. Understand? Okay? So, this is known as A belongs to A, the geometrical notation. Understand? Similarly, if B is not an element of the set A, is not an element of the set A, we can write, how can we write? The B does not belong to A. The B does not belong to A. And we can write it, we say B does not belong to A. This is the geometrical notation belongs to. If an element belongs to the set, we can write is an element of the set A, you can write it as a notation, set notation belongs to and does not belong to. Okay? Representation of set in set theory. There are different set notation used for the set theory to represent a set. Okay? So mostly there are three set notation we can use to represent the sets. First of all, semantic notation, semantic form, rooster method, rooster form, bias, mathematics and rooster, and the set builder form, property method. Okay, the three methods we can use to represent the set. Okay, here the semantic form. The semantic form is a set of past 5 natural numbers. A set of past 5 natural numbers. So here the set can be expressed in the form of statement. In the form of statement. This is known as what? Semantic form. A set which can be expressed in the form of statement is known as semantic form. And here the elements written distinctly, clearly, every element, all elements are written, including separated by comma and enclosed by curly brackets. This is known as rooster form. In rooster form, all the elements are written clearly, distinctly, okay, understand, by comma, and all the elements should be enclosed by the curly bracket. And builder form, this is the rooster form, and builder form. In this form, the set, this is the symbolic expression of the set. And this is the property method of the set. And every element has a common property. Using this property, okay, we can express a set that is known as the set builder form. Okay, so there are three forms. One is the semantic form in the form of statement, rooster form, writing the elements vividly, distinctly, clearly, and using the property method that is known as the set builder form. Let me discuss one by one here. What is semantic form? Yes, the semantic form is it is a notation of the set which can be described in the form of statement. A set which can be described in the form of statement we call semantic form. For example, a set of past 5 odd natural numbers in the form of statement is a semantic form. A set of natural numbers, okay, in the form of statement is the semantic form of the set. And a set of whole numbers, semantic form of the statement, in the form of statement. So, a set can be described, can be written in the form of statement is called semantic form. Clear? This is one of the way we can write, we can represent a set. The another method is known as similarly a set of integers also in the form of statement, semantic form. Okay? The another form is known as the rooster form, rooster method to represent the set. And in this set, every element, all the elements of the set should be written clearly, distinctly, separated by comma, and all the elements should be enclosed by curly bracket and separated by comma. For example, the set B. You see what kind of elements are there? Here you see 2, 4, 6, 8 and 10. These are the 5 even natural numbers, which is a collection of first 5 even natural numbers. So here it is in the form of which form? Rooster method. In the rooster form, all elements we have to write every element of the set clearly and distinctly. In rooster form, the order of the element does not matter. The order of the set does not matter. We can write the element of set in any order. And the set will never change. The set remains same. For example, the first 5 even natural number also can be written. We can write here, we can write 2 here, here it is written in systematic order. So order is not required while you are writing the element of the set. Here 6, 8, 10 and 4. You see, it's not in proper order. You can write the element of any order. Suppose geometry works, the elements you can keep the geometry works inside the geometry works elements or say the geometrical instrument in any order, but the elements are remain same. These are well defined. Also, if there is an endless list of elements in a set, so a set has infinite number of elements. Okay, so they are defined using a series of dots at the end of the last element. Look at here. For example, the infinite is represented set of natural number. You write 1, 2, 3, 4, 5. Again, dot sign are given at the end of the element 5. It shows that the set has infinite number of elements. It means it contains infinite number of elements and which we cannot count. How many elements of the set n we can count? And it's an infinite set. In these cases, we can express the infinite set by at the end of the elements by dot sign by giving the dot mark. The example of sets in the rooster form, look at here. The set of all natural numbers and n is equal to what? You see here 1, 2, 3 given by curly brackets. This is an example of set of rooster form. The set of whole numbers, capital W, which is 0, 1, 2, 3, dot, which is an infinite set. Set of integers, capital Z, is also an infinite set. And these are the elements are written in the rooster form. In this form, the elements are written clearly, precisely, distinctly, and all the elements must be enclosed by curly bracket. And every element is named by capital letters of English alphabet. Okay? And another form is known as the set builder forms. And in this set, every element, all the element has a certain property and rule. The set builder notation has a certain rule or a statement that has a common characteristic property. That is a common characteristics property, features. All the elements have a common property. So in these cases, we should not write all the elements clearly, and all the elements written in a single with the help of single variable. Okay, understand? And which stands for all the elements of the given set. And the set builder form uses a vertical bar line or semicolon in its representation with the text describing the characteristics of the elements of the set in the builder form. For example, the set A is x such that the symbol vertical bar line is known as such that yes, x is an even number, x is less than or equal to. It means the bar sign at the right side of the bar sign is represent what properties of the set, what kind of element should a set contain. Here x is an even number, elements should be even number, and x is less than or equal to 20. It means the element are equal to 20, all the even numbers equal to 20 or less than 20. The statement says that all the elements of the set A are even natural numbers that are less than 20 or equal to 20. Okay? And before the bar sign, here it is in what? The element. This is the element x with the help of the single variable, and what kind of element it should be on the right side of the vertical bar. This is the property and this is the element with the help of single variable, with the help of the set builder forms. Sometimes we can use the semicolon instead of vertical bar line, and which read as such that the symbol is known as such that this vertical line is known as such that we read as A is equal to the set A is equal to x such that x is an even number, x less than or equal to 20, x that such that. Okay, the semicolon and the vertical bar is known as such that. We read it. How to read the set? Very important. Example of set builder form. The set of all natural numbers in the builder form, which is capital N, is equal to, written here you see x such that x belongs to n. The set of all numbers, capital W, is equal to x such that, here semicolon we can use, x belongs to W. The set of integers, similarly, capital Z is equal to x such that x belongs to Z. Okay, so these are the basic concept of the set theory, introduced set theory. Here is an assignment for you. Okay, you try for the assignment here. Okay, and I have explained exercise 1.1 of your addition or solution, and you take toward the class, and also I am going to prepare the similar kind of class for you, the concept of important concept of set theory, and we will explain how the set theory is applicable, and different and set operation was the most important factor. Okay, understand? Next class I will discuss what is the different types of set. Okay, understand? So go through the class. Once again, thank you for interest and eagerness for the class. Jai Jagannath. Looking forward to the next class. Okay, thank you.